This is part 1 of our spring break packet. It's probably going to take me more than one video to go over all the questions. So go ahead and get ready. You should have a piece of paper that has all the numbers on it. I don't have it with me. If you don't have it, that's fine. Just get a regular piece of paper. Alright, let's get into it with number 1. We have a triangular banner is made according to the specifications in the figure shown with the dimensions given in inches. Again, remember, it's not so important that you know every word. You might not know what a banner is or specifications, but we're focused on the picture and the question. It says wooden sticks will be used to outline the perimeter. So this is a key word right here, perimeter of the barrier. Perimeter is the sum of all sides of a figure. So to get the perimeter, we would need this missing piece. Right? We have this measurement, these measurements, but we do not have this. All right, so let's finish reading. We are outlining the perimeter of the banner in order to attach the interior material. How many inches of wood sticks will be required? So again, all we need is this missing piece. This is what we're looking for. Since you're going to be taking this exam on a computer, it really helps to draw a picture. So let's just get in the habit of doing that. You can pause if you want to make it a little bit more exact, but again, it doesn't have to be perfect. You just have to get the idea. All right, whenever we have triangles and we're looking for a missing side and we don't have any angles, this is a Pythagorean theorem question. You can put PT for short if you like. And remember, that says that one side squared plus the other side squared equals the hypotenuse squared. So if we look at the triangle, this triangle, we're actually missing two sides. We're missing this side and this side. So we cannot directly apply the Pythagorean theorem. We first need to find this side, this altitude, which is not really a side. When we find this length, then we can use Pythagorean theorem to find this. So we need to use the Pythagorean theorem 2 times. So let's start with the triangle on the left. We know that since this is also a right angle, my hypotenuse is 13, and the hypotenuse always goes on the right side of the equation. So I like to start with x, so I'm going to put x squared plus 5 squared equals 13 squared. Double check, be careful, make sure that your hypotenuse is always on the right side of the equation. And then all we need to do is do our calculations. Right? In the calculator, everybody knows 5 squared, but if you didn't know 13 squared, there are 2 ways to do this. You can put 13 and then x squared. Or just remember that squared means times itself. So 13 times 13. All right, now we're going to need to subtract 25 from both sides to solve. And then here we're going to need to take the square root, and we get 12. Okay, so now we know, I'm going to just replace this with a 12. We know this is 12. And now we're going to need to repeat the process. This is our new x. So I'm going to do it one more time. X squared plus 12 squared equals 15 squared. Again, make sure the hypotenuse is on the right side of the equation. Again, if you don't know 15 squared, put it in your calculator. Boom. we're going to subtract 144. Which gives us 81, and then we're going to take the square root, and that equals 9. So now we have this is equal to 9, and remember this is on the inside, so this measurement does not count. We just need to add up, right, all of our measurements. So we have 15 plus 5 is 20. And we're going to add 13 and 9 and get 42. So the perimeter is 42 inches. And that's it. That's number 1. All right, let's go and take a look at number 2. Okay, so it says on the XY coordinate plane, triangle ABC, that's this one right here, ABC is dilated from center D. So this is your center right here to form RST. Okay, so we notice a couple things. First of all, it's clearly getting bigger, so that means that the scale factor has to be greater than 1. And this is pretty silly. It says in the figure the length of any line segment in the image. Okay, so we need to know the vocabulary. The image is the after. Okay, and the pre-image is before. Okay. So it says in the figure, length of any line segment is clearly longer than, right? The image, every segment is longer than the length of the corresponding segment in the pre-image. And the scale factor of dilation, if your only options are 1 and 2, obviously the scale factor has to be 2. Because in order to get a bigger image, you have to multiply by a number that is greater than 1. Now, actually on this graph, you can tell the scale factor by counting. Now, normally, actually, we can look at this side here. There's 2 ways. This side from A to B is 1, 2, 3. And this side from R to S is 1, 2, 3, 4, 5, 6. So we went from 3 to 6. So our scale factor, which we for some reason use K, is equal to 2. We multiply 3 times 2 to get 6. Our scale factor is 2. Now on this one, you can also look at the distance to the center. Because even though this is a diagonal, since the slope of the line is 1, we can actually count spaces. Normally, I would say most diagonal lines, like if we're looking at this dotted line, you cannot count because it doesn't connect from corner to corner. But we can see this line going through connects corner to corner. It's has a slope of 1. So we can count the distance, for example, from B to the center, or from D to B. We can count 1, 2, 3, 4. And if we count all the way to S, we should get 8. 1, 2, 3, 4, 5, 6, 7, 8. So this was a pretty easy question either way. All right, let's take a look at number 3. I guess you didn't really even need to write anything down, other than maybe you want to write some notes down that the scale factor is greater than 1. And maybe also remind yourself that the image is what we think of as the copy or the result. And the pre-image is the original figure. All right, let's take a look at number 3. Okay, so for number 3, it says in the triangle shown, Trish wants to estimate the degree of measure of angle theta. She knows that A is between 11 and 9, so this means greater than 9, less than 11. So A can be 9, 10, or 11, or anywhere in between if we're using integers. I don't want that to be confusing. Let's just say 9 to 11. And B is between 5 and 6. It says determine the greatest and least estimates of the degree of measure theta. Explain how you determined each estimate. So this is showing us that if we think about this angle, as theta gets bigger, B gets bigger, right? And A is going to get smaller. So if we want the biggest angle, we're going to have a very large B and a very small A, right? As this angle gets bigger and bigger, this length has to get bigger, and this one gets smaller. So if we want to think of the greatest, let's actually write this down here for number 3. The greatest, I'm just going to write, I want to have big B, small a. I'm just going to write that as a note. Big B, small a. Okay? And if I want the smallest or the least, it's going to be the opposite, right? So as this gets smaller and smaller and smaller, the B is smaller and the A is larger. So we're going to put small b, big A. Okay. I'm almost out of time with this video, so I'm going to talk a little faster. Okay, so the biggest B that we can have, the greatest B that we could possibly have is 6. And the smallest A that we can have, I think this is a 9. And then for the smallest B is a 5. And the biggest A that we can have is 11. All right, so what are we going to do with this? We're going to have to use some trigonometry, because here we're talking about an angle and we have sides. And we can see that this is the side opposite and this is the side adjacent. So we're going to find the tangent with both these values and these values. So let's start with the greatest. Tangent theta is equal to, remember, TOA is opposite over adjacent. So the opposite side is the B, this is O, and adjacent side is the A. Okay, so for the greatest angle theta, we're going to have tan theta equals 6 over 9. And for the least, we're going to have tan theta equals 5 over 11. So now we're going to grab our calculator, and remember, to get the angle we have to do the second button, second tan. We're going to do 6 divided by 9 equals, and we get 33.7 if we're rounding to the 10th. I didn't see how we're supposed to round yet. I'll come back to that later. And let's do tan theta, second button, tan, 5 divided 11 is 24.4. All right, let's check. Does it say nearest degree measure? I think that means we're going to round to the nearest whole number. So we need to round up here to 34. And this is going to stay at 24 degrees. If you have any questions, bring them up in class. At the end of this video, I can only record 15 minutes at a time, but go ahead and look for the next one.